Vast oceans of truth lie undiscovered before me. For a voyage into the mysteries of the universe, welcome to the Cosmic Front. This episode features the Yucatan Peninsula in Central America. The stairs of a Maya pyramid rise toward the heavens. Starting over a millennium ago, the Maya developed a sophisticated astronomy and created a remarkably accurate calendar. The Maya civilization originated around the 6th century BC, mainly in what is now southern Mexico and Guatemala. It collapsed in the 16th century AD. Only its ruins remain. Maya culture remains shrouded in mystery. Only recently have the writing symbols, or glyphs, on Maya stone monuments begun to yield up their secrets. Scholars tell us that the Maya achieved results that come astonishingly close to those of modern astronomy and calendrical science.
The calendar priests were, of course, very good observers of the sky, and so they were using their calendar system, such as the long count, this very elaborate calendar that we know the Maya had for a very long time.
The Maya reckoned the year to consist of 365.242 days. That's identical with modern measurements to 3 decimal places. They even grasped the periodicity of lunar and solar eclipses. A Maya text, known as a codex. This one contains records of the appearance of the planet Venus at sunrise and sunset. Deciphering this codex was key to realizing how thoroughly the Maya understood the complicated movements of Venus and how accurate their calendar was.
Es algo que, digamos, solo el astrónomo puede identificar porque aparecen periodos de tiempo, fechas que tienen gran significado para la astronomía y no necesariamente para el epigrafista o para el historiador, porque no maneja ese tipo de información.
Possessing no telescopes, how did the Maya observe the heavens and create such an accurate calendar? This episode of The Cosmic Front will reveal the secrets of Mayan astronomy. The lush Yucatan Peninsula in southern Mexico. Amidst dense jungle, a magnificent stepped pyramid comes into view. The ruins of Chichen Itza. The more than 60 edifices here, distributed over 5 square kilometers, constitute the largest remnant there is of Maya civilization. The symbol of Chichen Itza is this 30-meter-high stepped pyramid, the Temple of Kukulkan. Carvings of the head of the god Kukulkan adorn the front steps. In fact, one finds images of that deity all over these premises. The name Kukulkan means feathered or plumed serpent. It was believed to descend from the heavens, bringing fertility and abundance. It is the vernal equinox, and 40,000 people from all over the world have gathered for a glimpse of Maya culture. At 3 p.m., as the sun begins to sink in the west, the pyramid undergoes a transformation. It takes an hour and a half for the rays of the setting sun fully to highlight the undulating form of the serpent, and finally to join the celestial body to the head down on earth. Kukulkan, the serpent god, visiting earth in an interplay of stone and light. The secret to this deity's descent from the heavens at this time of year is hidden in the structure of the temple itself. The entire temple is a monument to sun worship. Each of the 4 stairways has 91 stairs. The 4 sides together have 364 stairs. Adding the rooftop yields a grand total of 365. As many stairs as there are days in a year. The pyramid diverges exactly 21 degrees from a true east-west axis. Herein lies the secret of its magical architecture. Let's animate the movement of the sun on the vernal equinox. As the sun moves over it, the pyramid acts like a sundial. As the sun sinks in the west, the 9 steps or levels of the pyramid are bathed in the light of the setting sun. The shifting shadows of the 9 levels create the illusion of an undulating snake. Truly an amazing temple, based on the Maya's intimate familiarity with the sun's movements. The day each year when Kukulkan descended to earth was a day of exceptional importance to the Maya farming class. On that day, the year's agricultural work began. Maya civilization was supported by slash and burn agriculture, a method still in use today. Fieldwork begins on the day of the vernal equinox. Planting is preceded by burning, so that the ash that is produced can be mixed into the soil as fertilizer.
De mayo, y no llovió en 3 de mayo, por el 20, por seguro que ya la lluvia. Cuando cae la lluvia nos vamos a sembrar, primero nos vamos a sembrar ¿cómo se llama? Es pepita. Las vamos a sembrar primero. Y después seguimos el elote. Así está acostumbrado años así.
With the rainy season fast approaching, the trees must be burned right after the vernal equinox. This is the practice that sustained the Maya. The Maya flourished over a vast area of Central America, including the Yucatan Peninsula. Their civilization arose in the 6th century BC and collapsed in the 16th century. It reached its zenith during the 3rd to 9th centuries AD. As many as 70 city-states jostled for power in the southern Yucatan Peninsula. In the 2nd century BC, one Maya capital was at Tikal. It was a kingdom that prospered from early on. A central plaza here was ringed with pyramids. Here, the king of Tikal conducted state ceremonies. From the very start of this civilization, the kings, though heads of state, were also considered to be deities themselves. Highly stratified societies emerged, with a king, an aristocracy, a farming class, and so on. In the 5th century AD, at the height of Maya prosperity, Copan was built. In this era, royal power was further strengthened. Numerous images attested to the king's authority and prestige. One notably large image is this stone sculpture of the absolute ruler of Copan. It was painted red, symbolizing the sun. A Maya king was regarded as the earthly embodiment of the sun god. However, around the 9th century AD, many of the Maya kingdoms of the southern Yucatan Peninsula collapsed. The center of Maya civilization shifted to the north. This shift was accompanied by a thriving trade in cocoa beans, jade, and obsidian. Mayapan was a capital built in the 12th century, toward the end of the Maya civilization. Here, one can still find a remarkable method the Maya used to determine the seasons. From this cylindrical building, one looks out toward a pyramid. The sun sets behind the pyramid only for a 40-day period each year, starting with the vernal equinox. The pyramid told the Maya when to start that year's farm work. Thus, the Maya civilization persisted for over 2 millennia, revering the sun and conforming to its dictates. However, in 1519 AD, invaders suddenly appeared. A Spanish expedition had crossed the Atlantic. The Spanish saw their conquest as an opportunity to wipe out what they considered a heretical pagan culture. Thus, the curtain was drawn on 2,000 years of Maya civilization. Mexico City, the capital of Mexico. A scholar at an institute here has been trying to recover the lost civilization of the Maya for over 20 years. Jesus Galindo Trejo. His specialty is archaeoastronomy, exploiting a variety of materials, including murals and architecture. He strives to get a sense of what Maya astronomy was all about. Jesus Galindo was originally a solar astronomer. As a young man, he studied for a while in Germany. Learning, however, of a much earlier tradition of astronomy in his native Mexico, he switched fields. He wanted to focus his studies not on the sun itself, but on the mysteries of Maya astronomy, which served a culture that worshipped the sun. His current research takes him to the southern part of the Yucatan Peninsula, to Calakmul. This Maya center flourished from the 2nd century BC to the 9th century AD. But it suffered a mysterious downfall. The jungle swallowed it up, and it was forgotten. The city was not rediscovered until the first half of the 20th century. Research here is ongoing. Jesus Galindo arrives at a plaza in front of a pyramid. The pyramid stands 50 meters high. This was Calakmul's main temple. Ascending a steep staircase, the king, a god himself, would conduct official ceremonies. As an archaeoastronomer, Galindo is undertaking a detailed study of this pyramid in an effort to ascertain its astronomical significance. His tools are not those of an ordinary archaeologist. He uses surveying equipment and GPS technology to take precise measurements of the pyramid's location and orientation.
En este caso tenemos que tomar un punto de referencia en el cielo, que en este caso particular es el Sol mismo. Con esto vamos a medir respecto al cielo, respecto al norte del cielo, cuál es esta dirección. Además, el instrumento tiene que medir la altura de la línea de visión. Con esos dos datos podemos calcular cuándo en el año el Sol observado desde aquí va a aparecer en la misma línea de observación.
The temple at Calakmul is now overgrown with dense jungle, but archaeological surveys have revealed the city's layout in its days of glory. Thanks to 20 years of research, the astronomical significance of its 4 temple buildings is at last understood.
Este sería el punto de observación. Estos edificios, aunque en la actualidad están cubiertos en su mayoría por árboles que no permiten ya la observación, según los datos arqueológicos, hay subestructuras aquí abajo que apuntan hacia por lo menos 200 años antes de Cristo. Sería un punto ideal de observación donde podríamos ver a través de seguir cada mañana el surgimiento del sol enfrente.
Given the encroachments of the jungle, computer graphics will be helpful in recreating Calakmul's appearance in its heyday. 3 outlying pyramids face the main temple, centered on an east-west axis. Let's look due east from the temple proper. On the vernal and autumnal equinoxes, the sun rises directly over the middle pyramid. At the summer solstice, it rises from behind the left pyramid. At the winter solstice, from behind the right pyramid. These temple buildings, consecrated to the sun, attest to the powerful motive behind the advanced Maya astronomy. This temple of Calakmul was built around 200 BC, truly a remarkable understanding of astronomy for such an ancient culture. Suddenly, in the 9th century AD, all traces of human habitation vanished from Calakmul. The city was swallowed up by the jungle. The cause is still a mystery. Ancient Calakmul boasted a millennium of prosperity. In front of its magnificent temple, generations of kings erected sculpted stone monuments called stelae. About 120 of them, all in a row. They are inscribed with Maya glyphs.
Bien, estamos ante la estela 29, una de las más de 120 estelas que se han encontrado en Calakmul. Este es un ejemplo un poco destruido, pero que muestra la estructura de cómo se expresaba una fecha en la época clásica.
The soft stone has suffered terribly from erosion, but some of the glyphs can still be made out. These 5 glyphs reckon the number of days from the beginning of the world to the time of the Maya. Beneath them is inscribed a solar almanac. This represents 13 Pope, that is, the 13th day of the Maya month called Pope. Let's take a look at the entire Maya calendar. Our year is divided into 12 roughly equal months, but the Maya month was only 20 days long. The numbered days started from 0. There were 18 months, all given names: Pope, Mol, Yash, and so on. But altogether, they added up to only 360 days. The remaining 5 days were called Wayeb and designated a special period of preparation for the new year. To prevent further erosion, Maya stelae in good shape have been removed to a museum. Some are from Calakmul. This one is 4 meters tall. On it, in relief, is carved a crowned figure enveloped in sumptuous robes, the Sun King. Invariably, these stelae are also inscribed with glyphs. Here one can make out a day and a month in the solar calendar, the 13th of Yash. By chiseling accurate calendrical data in stone, the Maya passed along vital information to future generations.
Estamos enfrente de la estela 52, o más bien de lo que queda después del saqueo de la parte frontal. Sin embargo, quedó por suerte las laterales todavía con inscripciones calendáricas. En particular, esta estela muestra información calendárica que, según el investigador Eric Thompson en el siglo pasado, planteó como una manera para demostrar cómo los mayas, al darse cuenta que la duración del año no es 365 días y 6 horas, sino que si no se hace una corrección se iría desfasando.
This stela is inscribed with the date it was built, 7 Mol, or 731 AD. Here is the full Maya calendar. The Maya dated the beginning of the world to the year 3114 BC in the Western system. 4,000 years later, in 731 AD, they erected the stela that was just shown. Let's count by leap years to get a more manageable number for the entire span of years. That Mayan date on the stela, 7 Mol, marks the 931st Mayan leap year since the world began. Now let's count the number of leap years according to the Julian calendar. That's a calendar used in Europe in the 8th century AD, around the time that stela was erected. We arrive at a figure of 961 leap years. That also yields a 30-day discrepancy with the Maya calendar. Modern astronomy, however, reckons the correct number of leap years as 931, exactly in agreement with the date carved on the Maya stela.
Esta inscripción señalado, justamente el número de días es la inscripción 7 Mol, el número de días que se habría desplazado el Sol y que era necesario corregir. Si esto es cierto, se habría planteado la posibilidad de que los mayas habrían llegado a la duración del año solar con mayor exactitud que en su momento tuvo algún calendario europeo. Esto podría mostrar claramente un gran avance en la astronomía de los mayas que lo pondría para su época en los líderes de la observación del cielo.
What does a calendar signify in modern astronomical terms? One day means one rotation of the Earth about its axis. 1 year means the Earth's completion of a full circuit around the Sun, what's called an orbital revolution. The Earth takes approximately 365 1/4 days to revolve around the Sun. The Julian calendar reckoned the year as containing 365.25 days. Modern astronomy, however, holds a year to consist of 365.2422 days. And the Maya calendar reckoned a year at 365.242 days. The Maya calendar was accurate to 3 decimal places. The Maya calendar was objectively accurate, yet it also reflected a uniquely Mayan sense of time. Texas, USA, home to a scholar devoted to deciphering the glyphs that are the keys to Maya culture. Meet David Stewart. His analysis of the glyphs on Maya buildings and stelae has made him the foremost expert on the Maya writing system. Stewart published his first scholarly article as a precocious 12-year-old. Both his parents were archaeologists, and during his childhood, the Maya ruins had been his playground. Since then, he has tackled the decipherment of the Maya script with great determination and ingenuity. solving one riddle after another. Some glyphs are patterned on human figures, some on animals. Still others are complex geometric shapes. So far, some 80% of Maya glyphs have been deciphered. Thanks to that decoding, the secrets of the astronomy behind the Maya calendar are also now largely understood.
Many civilizations from the ancient past were aware of the planets and the stars and tried to give meaning to them. But for some reason, the Maya, ancient Maya, conceived of time on such a huge scale beyond what any other civilization really ever did. The calendar priests were, of course, very good observers of the sky, and so they were using their calendar system, such as the long count, this very elaborate calendar that we know the Maya had for a very long time. They were using the long count to record, for example, the intervals of time that they observed. So the long count calendar, which is a count of days, a very accurate count of days, is a way of keeping very precise records.
The long count was a system by which time was measured in units of days, starting with the year the Maya believed to be the beginning of the world, equivalent to 3114 BC. As its name indicates, the long count piled up an endless succession of days only, one at a time. This absolute linear temporal axis made it possible for the Maya to record their observations of the sun accurately for nearly a millennium. David Stewart posits that this is also why their calendar could measure 4,000 years of history with less than a one-day margin of error. However, there were serious obstacles to making the long count the regular calendar. As the Maya entered their period of greatest prosperity in the 3rd century AD, their long count had surpassed 1.2 million days. They had to manipulate dauntingly large numbers.
It's a very, very elegant and complex mathematical system that the Maya used for computing their days and their years and periods of time that are far, far larger than any that we have in our own calendar.
So how did the Maya count? 1 dot is 1, 2 dots are 2, 3 are 3, a bar is 5, 1 dot 1 bar makes 6, 2 dots 1 bar makes 7, and so on and so forth. 4 dots and 3 bars make 19. And then they had a 0. The Maya represented each of the numbers from 0 to 19 with a single glyph.
The Maya used a base 20 system of counting, which is different from our base 10 system. So the smallest unit would be the unit 1, but above that would be 20, and then multiples of 20 on top of that. So above that would be 400, and then 8,000, 160,000, and so on. So in representing a number, they would use these units in a place notation system and give them multiples.
The Maya's base 20 system can best be shown vertically, with the highest values at the top. For example, the Maya needed only 5 glyphs to express the number 2,933,865. Let's compare how this would have been written in the Roman numerals in use in Europe at the time. That required all of 17 letter symbols. Now let's look at the same number in Chinese. That takes 13 characters. The Maya base 20 system could express enormous numbers in a compact form. That made it the most advanced number system in the world. The long count reckoned time day by day from the beginning of the world. These Mayan glyphs state a long count date of 1,364,400 days. An enormous number, expressed in just 5 glyphs. It was their unique base 20 number system that enabled the Maya to record their observations for as long as a millennium. This is the secret to the accuracy of the Maya calendar. In Chichen Itza, not far from the Temple of Kukulkan, there is another building that reveals secrets of the Maya calendar. The Observatory of El Caracol. That name, meaning the snail, derives from the structure's spiral design. It was built 1,200 years ago. Precise measurements of this building show it to have a remarkable structure. Its 2 foundational levels are oriented in different directions, and both of them depart from a true east-west alignment by more than 20 degrees. The observatory proper has 4 entrances, facing north, south, east, and west. Inside, a corridor follows a circular route. Presumably, the purpose of this shape was to enable observation in all directions.
De tal manera que, por ejemplo, lo más peculiar aquí es que justamente la línea que une las jambas exteriores con las interiores señalan a través de la diagonal direcciones en el paisaje que tienen que ver en la época en que esto estuvo funcionando, señalando la posición de diferentes astros en el cielo. Así, por ejemplo, aquí adentro podemos ver cómo se forma una rendija entre este canto, y desde aquí se ve bien definida una dirección que señala en la dirección en que se va a poner algún astro importante.
Celestial bodies can still be observed from the second floor as well, along similar diagonals. Most of the second floor is in ruins, but 3 small windows do remain. This one looks out toward the western horizon. At the vernal equinox, the setting sun can be observed along a diagonal created by the inner and outer jambs of this window. The path indicated by the window and the actual path of the sun differ by less than 1 degree. Observatories such as El Caracol help the Maya to chart the sun's movements with precision, and thus to create an accurate calendar. Once again, computer graphics can help visualize the ancient methods. The red line indicates the direction of the setting sun during the vernal equinox, that is, west. The same window's other diagonal, diverging from due west by 29 degrees, points in a northwesterly direction. It aligns perfectly with the center of the outdoor stairs. This also has astronomical significance.
En particular, la ventana central está en tal disposición construida que la línea que une las dos jambas señala hacia el poniente la posición de Venus cuando se pone más hacia el norte. Si uno tuviera enfrente al edificio y permaneciera en un lugar fijo, uno podría ver a lo largo del tiempo cómo Venus va cambiando de posición, y probablemente esa sería otra manera de seguir el movimiento aparente de Venus.
Venus, known as the morning star and also as the evening star. Next to the sun, Venus was the heavenly body of greatest importance to the Maya. Professor David Stewart of the University of Texas keeps a facsimile of an ancient document that records details of the Maya's meticulous observations of Venus.
Here it is.
The Dresden
This
Codex.
is a copy of an ancient Maya book.
Once labeled heretical, it was ordered to be burned.
A photo
Today, there are only 4 extant copies in the entire world.
for understanding ancient Maya.
It shows Maya astronomy to have reached a level far more advanced than generally believed.
What we have here are very complicated and ornate astronomical tables. In this case, in these 5 pages right here, 1, 2, 3, 4, 5, what we call the Venus tables, because this was a section of the book devoted to the interpretation of the movements of the planet Venus.
In the Mayan language, Venus was called Chak-Ek. Ek meant star. Chak meant great. So Venus was the great star.
At the bottom of each page were these numbers painted in red, here and here and here, and on the other pages. And they are the same numbers, as you can see. 11 and 16, 4 and 10, 12 and 10, 0 and 8. The total amount of time represented here is 584 days, which is a full Venus cycle, a full revolution of Venus around the sun.
The angle and elevation of Venus, as viewed from Earth, changes day by day. And those movements are complicated. Venus first appears in the east, just before sunrise. Every day, its position changes. Some 9 months later, after a convoluted passage, it disappears from the eastern skies. For 2 months, Venus is not visible at all, Then it reappears close to the western horizon just after sunset, and once again undertakes a convoluted passage through the skies. The cycle to this point has taken 575 days, after which Venus disappears from the western skies. Then, after a hiatus of 8 days, Venus reappears back in the east. To this point, the cycle has taken 584 days. Thanks to their observations of heavenly bodies, the Maya knew this Venus cycle intimately. The 584-day Venus cycle is mentioned repeatedly over the course of 5 pages in the Dresden Codex. Why was the same phenomenon mentioned 5 times? The key to a solution of this riddle was carved in stone on a Maya ruin. Near the Temple of Kukulkan lies a building called the Temple of Venus. Glyphs signifying Venus are inscribed everywhere here. At this temple, a stone tablet has been found in which Venus is mentioned in conjunction with the rod that signifies 5. Also on this tablet, a term meaning solar year occurs together with 8 circles or dots, each signifying the number 1. So the tablet is known as the 5 Venuses equals 8 Suns tablet. 5 times the 584-day Venus cycle equals 2,920. 8 times the 365-day solar cycle equals 2,920. Exactly the same. Here's the reason why the Venus tables take up 5 pages of this codex. 5 Venuses equal 8 suns. Let's interpret this equivalence by the light of modern astronomy. Venus and Earth circle the Sun in different orbits, but at regular intervals, all 3 objects will draw close and line up. Once every 584 days. The 5th such lineup occurs once every 8 years at the same location as the first. The Maya knew that Venus and the Sun had a deep relationship, expressed in the simple numbers 5 and 8.
Sabemos la importancia que tenía Venus para los mayas, tanto en códices como en pintura mural, como a través de orientaciones venusinas, están mostrando la importancia que tenía Venus. Yo considero que la observación de Venus fue fundamental, extremadamente importante para calibrar una de las actividades fundamentales para la cultura maya, que fue la cuenta del tiempo.
For the Maya, the heavenly alignment between Venus and the Sun carried a meaning that went beyond astronomy. During the 8th century AD, when Maya civilization was at its peak, the Mayan city-states were frequently at war. One great struggle occurred during the reign of King Chan Muan II of Bonampak. These murals are inside a temple he ordered built. They escaped total destruction and have survived for 1,200 years. A warrior with a spear. A prisoner of war pleading for his life. It's a mural commemorating a victory by King Chan Muan II. the mural duly notes the day the war commenced. The date given in glyphs, 13 Chikchan, 13 Yash, corresponds to August 6th, 792 AD. Calculating the positions of the planets on that day shows that this was a special day astrologically. On that day, the Sun, the Earth, and Venus were all in alignment.
La fecha que aparece aquí pintada corresponde justamente a ese momento, como una manera de resaltar la importancia que daba el que mandó pintar esto a sus triunfos militares. Eso podría apoyar la interpretación de que los mayas asociaban el momento de ir a la guerra con la aparición de Venus en el cielo.
The Maya thought of Venus as the god of war. For the sun, the heavenly symbol of the king, to be in alignment with Venus, god of war, meant that it was a propitious time to launch a military campaign. Venus and the Sun combine in an even rarer phenomenon known as the transit of Venus. Just a few times in each century, Venus will actually pass in front of the Sun. Jesus Galindo says that the Maya knew even about this rare phenomenon. This mural was painted in the 13th century AD.
Básicamente consiste de rectángulos polícromos donde en el centro aparece un disco solar. Su forma circular, los rayos de aspecto similar a en otras regiones de Mesoamérica, y aparece un personaje descendiendo.
Galindo says that this human form is really Chak-ek, Venus. Venus passes in front of the Sun for only a few hours. Yet the Maya observed this rare astronomical phenomenon and described it in a mural. The last time this phenomenon occurred was in mid-2012. Also, one day in 2012, the long count will arrive at the close of one of its constituent periods. The fifth glyph will reach a turnover point, and one era will come to an end. That date corresponds to December 23rd, 2012. It has often been represented as the date the Maya predicted for the end of the world. Chichen Itza. These ancient ruins are now thronged with visitors. The Maya continue to exert a fascination over us.
Very nice to see. We're coming all the way from Canada, so we have to see it while we're here. We might not be back for a long time.
Have you ever heard of the prediction of Maya 2012?
Yes, a little bit, yeah.
How do you think about it?
Well, I don't think it's true. I hope it's not true.
No sé, bueno, al menos yo no me aferro a eso, ¿verdad? A esperar a ver qué pasa, ¿no? No creo que vaya a pasar nada.
The Maya were sun gazers and sun worshippers. They prospered for 2 millennia developing an advanced astronomy and creating an astonishing calendar. Their civilization is now gone, but its remnants here show us that the Maya once stood at the cosmic front. Modern astronomers may have new methods, but they share with the Maya a questing spirit, transcending time and space, as humanity continues to probe our endlessly mysterious universe.